And then I remembered it's like, oh, because it sucks to design a PCB. It's absolutely zero fun, right?
From EE Tech Media and All About Circuits, this is Moore's Lobby. I'm your host, Daniel Bogdanoff. I have a confession. I muted the words AI and GPT in my Twitter feed just for the week because it seemed like every other tweet and news article was talking about it. It's inescapable, and honestly, I have the rest of my life to read about it, and I just needed a brief break. But there are a lot of fascinating things happening in the world of AI right now, including, as it turns out, in PCB design tools. Today in the lobby, we're joined by Matthias Wagner, the CEO of Flux, whose goal is to take the heart out of hardware. Fun fact, Matthias also produced the music for one of the world's most viral YouTube videos of all time, but you'll have to stick around to the end to hear more about that. Matthias, thanks for being here today. I'm really excited to have you.
Yeah, thank you, Daniel, for having me. Very excited.
I'm curious, how did you first get into science and technology?
I love to build things. I mean, that started with like wooden blocks and Legos as a kid, Lego Technic and all that kind of stuff. My dad and my uncle, they're both engineers. My grandpas were mechanics, or my other grandpa was a carpenter. I come from a line of people who build things, and that's how I got into that too. And people always want to put me in a box, right? To be a software engineer or hardware engineer. And I'm like, no, I just love to build things, Or like, I'm a founder, CEO. It's like, no, I just really enjoy building things, that's it.
Do you feel in the CEO role kind of trapped as like a business person when you want to just be building things, or how does that play together for you?
That's a great question. I mean, it turns out you have control over defining what your role looks like. I got to witness a couple CEOs in my career. I worked at Facebook and saw Zuck there do his thing and realized, he's organized it in a way that works best for him, that leverages his talents, Like he hired Cheryl there because, she was a great business leader. And that wasn't what he thought was his strength.
And where are you from? What is your technical education?
Yeah, good question. I'm from Germany originally. And technical education is, I went to a private college there funded by Siemens, where I got the actual title is Systems and Information Technology Engineering or something like that. That's the best translation I can offer.
Okay.
I mean, it was very broad, actually. There was even like a 6-week course in metalworking. But yeah, we did like a lot of the telecommunication systems that Siemens offered at the time, software, firmware, hardware there, the whole thing. Yeah, it was really broad. It was cool like that. At the time, I felt like, oh man, I wish this was more of the stuff that I want to do and less of all the other stuff, like, 6 weeks in a metal workshop. But this all worked out in my favor across my career, that I knew at least enough of some of these things to know where to start.
And it definitely seems like that has paid off for you, and we'll dig into that more. First, though, you mentioned the college was founded by Siemens. Did you go work for them?
Yeah, how this worked is that you spend like some time in school just learning and some amount of time there, like, being part of some of their teams, So I did a bunch of different stops there. I was on a team where it was actually really fun. Siemens has a lot of like very old systems at place the customers, like Volkswagen, for example, and some system there on the assembly line would fail, and we would come in there, find the thing that failed, and then there would be some computer from the 70s. There was no documentation, no replacement parts, and then our job was to figure out how to fix that thing again, make it work again. With oftentimes no documentation and it was really detective work, real reverse engineering work, and then either to fix the thing and really with the soldering iron be like, okay, a capacitor exploded here on the board, let's just, replace that, or find another machine that wasn't used anymore and scrape replacement parts for that, or figure out a replacement, be like, okay, look, this computer is done here, how can we replace what this is doing with like a modern machine, And so that was really cool because it was so, you never knew what would happen tomorrow and what we would encounter and what crawl space you would crawl. And it was that on that team, it was me and one of the full-time employees there. And we would just venture out, with our ticket and try to figure out a solution for the customer. And, in some of these cases, assembly line is stopped. So there's urgency too. So it's that kind of stuff. In other cases, I was involved as a software engineer. I was involved with like a planning software for a nuclear power plant that Siemens was building, which was fun because, the These projects take like 50 years to complete.
Huge.
And everybody who was there knew that we wouldn't see this project finish, right?
That's crazy.
And so, yeah, it was cool. It was really broad. I got to do a lot of different things.
Can you describe the best day on the job and the worst day on the job in that role?
Well, I'm going to tell you this from the perspective of the young me who was there at the time. I think the best day of the job is when I discovered that they had fiber internet.
Oh, yeah.
And that I could easily set up my own servers there and use that fiber internet for my own purposes. That was fun. Another cool moment was like when I realized, they had this amazing internal library, and I could just, any book I could think of, they would just send it to my desk.
That's cool.
And that was really cool, especially like this is like, we're talking like 97, 98. So at least in Germany, right, internet wasn't that broadly available. German content wasn't that broadly available. And like, especially like technical hardware, software engineering books were hard to find in the public libraries. I remember that as a younger teenager, I spent a lot of time just going from town to the libraries to try to find the books that I cared about software engineering or whatever it may, right? And you would find this like really broad, generic stuff, right? But not the actual in-depth stuff. So anyways, that was really cool. When I realized, any book? And even if they don't have it, then they'll buy it and they'll send it to me.
That's wonderful.
It's just like,
Yeah.
That was awesome. Now with the internet, that's all old news. You don't need that anymore,
Any like horror stories from weird crawl spaces or anything like that?
Oh, plenty. Yeah. I mean, it's sometimes really awful because nobody has gone through there in like 2 decades or so, It's really remarkable. It's also cool to see also like how, you think about like something like Volkswagen, an assembly line that's so crucial, right, to their business, to be like a very planned and architectured piece of machinery. And it turns out there's a lot of like, you see like a KUKA robot's marketing video, and it's also designed and streamlined and perfect. But then you actually get there and you realize, they have that exists on one side. But on the other side, there's a bunch of like one-off systems that somebody just, put together on a tough timeline, and it just worked for 3 decades without hiccups. And now it stopped doing its thing, and nobody even knows where the thing that does the thing even is,
Yeah.
Or what its exact spec even is, It's just, it made that light blink, and then this happened, and now it doesn't do that anymore. So you guys need to figure out now, right?
Sounds like you would learn a lot and get really good at, reverse engineering and being scrappy.
Yeah, I think what was cool to see is that no matter how hopeless the situation sometimes looked, we would figure out a solution in the end. Yeah, I think that was just good to experience as a young person, that like you just be systematic and you keep at it, and you keep being like, by the scientific method here of like hypothesis, and then trying to prove that hypothesis, you would figure out the solution.
Yeah.
That was really powerful. I remember to see that actually.
So and then you pivoted from that into music, and had what seems like by the numbers a pretty successful musical career as a songwriter, producer, label.
Yeah. So that was like a passion I got into. I like making things. I think there's a creative aspect to that. I think then through the love of technology and art and techno music is on the intersection of that. You can use computers to make techno music. This is essentially the original symbiosis there, I guess.
Yeah.
And so I got into that. And then, like I said, I think the thing that was fun, but at the time I think I was often frustrated that it wasn't more of the thing I wanted, and a lot of the stuff that I, at the time, didn't see much value in, And so then I did the Siemens thing for like almost 3 years. And then I think I had 1 more year to go. So now I was like, the music thing, there was like, I got like signed on a label for the first time. And so I was like, they paid me like $1,000, and I thought, here, I made it, I pivoted my career then, and got into the music thing.
Looking back, how do you feel about that choice?
That was a really dumb idea at the time, but I made it work. I would like today, if somebody asked me what their kids should do, or when I think about my son, I'm like, I'm not quite sure what I should answer here, Because this was pretty reckless, I should have just finished that last year and then, then do whatever I wanted to. Instead, I was just like, I did what I did, and it worked out for me. And maybe that was good to have that pressure, because that then provided the motivation. So it's hard to say. Here from like this one sample set of data, I would say this worked out really well for me.
Yeah, sample size of 1, it worked out.
Yeah, exactly.
Well, so in my notes, it says over 100 records and sold 1 billion units worldwide.
Yeah.
100 records, first off, that is a lot. Were you producing? Were you the label? What did that look like?
Yeah, we did all of that. I mean, I come from a small mining town in Germany, the thing at Siemens, I was like in the next largest city, Hanover, which was like, 45 minutes with the train to get there. So in this small town, right, we were like, it was me and a couple of friends making electronic music in our basements. And I think, starting the label was just like, that was the only way to get our music distributed. But again, you have to think this is all before internet distribution was a thing. At the time, we had at best a dial-up modem.
Yeah.
The idea to distribute MP3s over the internet was like far away. It was a dream we had, but nobody else believed would ever happen. So, we were back to like just vinyl and CD distribution, and nobody in a big city in Berlin cared about us. We just did it on our own, So we would just take $1,000 and press as many vinyls as we could from that, and then just call the record shops in the country. They want to just order 10 of those, and enough of them did, and that's how it all got started. That's where I learned how to run a business by not running a business at first. I remember there was like very fondly there was a pivotal moment. We had like by then we had like a larger, like the Europe's largest independence label, Edel Music. They were doing our distribution at that stage, and they called us one day. It's like, hey, look, the ROI here isn't great, guys. And I'm like, ROI, like return on investment? And then the first time I realized, yeah, right, they are a business. And if we're costing them more money than we're making them, that isn't going to work out well, But up until that point, it was just really like, more artistically driven, I guess you could say. But that was a good learning point, right? It was like, oh yeah, right, this actually matters. Somebody adds all these numbers up at the end, turns out, and found out that we weren't ROI positive here.
Well, speaking of being ROI positive, it's time for a quick break. We'll be right back. This episode is sponsored by NXP. NXP breakthrough solutions and technologies take industrial customers further, faster. Accelerate the shift to intelligent automation. Greater flexibility, resiliency, and higher ROI across intelligent factories require advanced automation technologies. NXP offers the building blocks for sophisticated industrial automation systems that synchronize and orchestrate system and motor control, HMI, and movements throughout the factory. Please visit nxp.com/factory automation for more information. That's nxp.com/factory automation. And we're back with Matthias Wagner, CEO of Flux. I have fallen into the modular synthesizer part of Twitter, and I love it. And I'm a musician myself. What can people in the electronics industry take away from techno and from the music industry overall?
Ooh, I mean, a lot of things. And a lot of things I think that we're like having started Flux that we're trying to bring to it is that, I started making music in the early 90s when you needed like very expensive outboard gear, analog gear, or like the first digital gear came out to record a proper track. I mean, one reason we resorted to making techno is because it was simpler music and you didn't need a multi-million-dollar recording studio. And then I saw all that change to be done in a laptop in the early 2000s. I was a beta tester at Steinberg, who makes like a very popular recording piece of software called Cubase, right? And I saw the whole transition happening there firsthand, contributing to that as a beta tester and providing input. And so, right, recording software and tools before were machines supposed to be operated by professionals, like an audio engineer with a degree and whatnot, and also, even the budget to have that kind of gear, you needed to be part of some sort of professional institution. And that reminds me a lot of like how PCB and electronics design works. You have to work at Lockheed Martin. Otherwise, there's just no way you're going to, do this by yourself. And it has to go in a waterfall process. And we're going to work on this for 10 years. And then, And so, the whole process in the music industry changed then, to be done on your laptop by then, therefore, an amateur, like a school kid in a bedroom. I think there was one piece, yes, digitizing the whole process and putting it into a computer, but also like thinking about the user experience differently, right? Making things, less like a audio recording tool and more like a instrument. Like if I use a guitar, that thing doesn't bother me with like storage space and modals on top of modals, and cryptic error messages. No, it's just gonna, you do something and it's either you like the sound it makes or you don't. And then you keep iterating,
Yeah.
And so I saw that applied to software, right? Like Cubase and Logic at the time were already far better than something like Pro Tools, for example, which was like a very industrial piece of software. But then Ableton came along in the 2000s, and that was like another giant leap for it to be much more fluid, less interruptions, right? Allowing you to really focus more on the creative process and not worrying so much about the technology that was involved to enable all that. And so I think when we, as we build Flux here now, right, which is a hardware design tool, we're approaching this the same way. We don't want interruptions. We don't want to disturb you. We don't want you to have to go with your mouse across the whole screen to do something that you do a lot, right? We want you to have that all in front of you, right? And so a lot of the design principles we have, right, that not taking you out of the flow, like everything is real time. You don't have to like reload something or stuff like that. No, it's all here, That's incredibly important to us.
Yeah, the idea of it being more about the creation than the tool chain. Installing tool chains is not fun for anybody ever, I would say.
Yeah, exactly, right? Like importing, exporting, converting files to get them into another tool. I think it's another piece, right? Just having it all here in front of you, right? And not dealing with repetitive tasks. But again, the issue is that a lot of the industrial tools, let's call them that, right? They're typically designed around like a team with multiple people, with experts in different fields, and sure, they might be able then to operate that, but it's really also in the way of the creative process of creation, whether it's music or a podcast or a PCB board, right? And so removing more of that, abstracting that and simplifying that and empowering the individual to just iterate themselves and have a fast feedback loop too, Like in music now, like in Ableton, you can make the track, export an MP3, send it to some friends, get feedback, and go back. It's really fast compared to like, oh my God, spin up the whole recording studio, put down like a recording on like a DAT cassette or something like that, sending that via mail, right? It's just like a lot of latency, right, to get your feedback. And like something I think in getting into software that I appreciate is like, you write the code, you compile, you test, you adjust the code, and it's a really fast loop. And I think that makes, right, this ability to iterate fast and cheaply is a huge lever in software, which is why it's so popular, right? And so again, just the desire to bring more of that idea into electronics design and to hardware design.
Absolutely.
Because again, but I love building things. And I realized that this is how I came across the idea to start Flux. That I love building things, and why do I not build more hardware? It's because it's so cumbersome,
Yeah.
Why do you think this by yourself? And I just got so frustrated. I started talking with friends about that, and I realized, it isn't just me who's frustrated. It turns out a lot of people I know in software came from hardware. They have EE degrees and whatnot. They just got into software because it was so much more enjoyable to do. And you get so much more results way quicker. And I knew a lot of EEs who were working as an EEs who were highly frustrated and so jealous of their counterparts in software and other fields around the tooling and the workflows that they had. And, they were stuck here spending the weekend in a conference room diffing schematics with colored markers,
There is something magical, though, about walking away with a board that actually, like a piece of hardware that works.
Oh, yeah, for sure.
So it definitely has that upside, but getting there is so hard.
Yeah, I moved to Silicon Valley like 13 years ago now, right? And I worked mostly in software here in Silicon Valley. And so I discovered Burning Man early on, and it became this canvas for me to build physical things, right? And I often told people, this is my therapy for making software, because software is never finished, right? That's one of the downsides. Because it's so easy to iterate, it's never done. You can always just fix this one more thing, add one more feature, make this thing a little faster. And hardware is so much more finite. Whether you're making a chair or a PCB board, it's like, no, here, it's there now. It's doing the thing. And that's I found that very therapeutic. So it's like on my daily commutes to Menlo Park, I would do that,
Yeah, I saw some of your Burning Man builds, the Hotel California. Mm-hmm. First off, what is Burning Man for folks who are somehow not familiar with it? And what does it mean to you in the technical community?
Yeah, good question. Burning Man, for those who don't know, I would describe as a arts festival in the Nevada desert. It's like an annual event, 80,000 people. What I enjoy about it is going to be very different from what the next person enjoys about it. So don't take my answer as the ultimate answer. It's so diverse and what drives people there and what they do there. That I'm just going to speak for myself. But yeah, no, I went there the first year I moved to San Francisco, because that seemed like the thing that everybody did. And I'd heard about it once, about an art thing. I was like, oh yeah, no, I like camping. Desert sounds cool. I'm just going to go. And I just realized quickly what an incredible canvas it was to just do whatever you wanted without any constraints. And which is like a lot of people who were like, whatever you would show up with there, they would love it, because people were so open to new ideas and to weird ideas and to helping each other, right? I remember this fondly, like one of the aha moments I had is like, I got there my first morning, set up camp, and I was like, I don't know, it's like Monday, 8 a.m. or so, we had like driven through the night. I'm just going to go for a walk here around the neighborhood. To me, it looked like a campground in the desert, It didn't look like much else. And then I come what they call the playa, which is like the city is like kind of like circular, and so there's an inner piece that's open, it's called the playa. And I walk across that, and it just blew my mind, because there was a predator surfing a surfboard that was mounted on an e-skateboard, and there was a pier there, and he was surfing around that pier, and I was like, "Nah, this is not what I thought it was going to be, right?"
Yeah.
There's clearly all these ideas of different people. Somebody thought of the pier, somebody else thought about the predator thing, and the next, I was like, this is fun. So anyways, that's how I got into it. That's what excites me about it. We then started out. I like doing my own thing. I'm like anti-authoritarian, I guess. That's probably also why I dropped out of Siemens, because there was other people telling me what to do. And so, we started a camp with some friends, and it just grew bigger.
To the point, I saw you develop some power systems.
I don't know much actually about combustion engines, ICE engines, and you need electricity out there. And the default solution at the time was a generator. And, I didn't know how to maintain the thing. I didn't know how to fix the thing. And that bothered me. And then one of my campmates, they started just 2 car batteries and a solar panel. Right. And it turned out that was enough with LED lights, you can go a long way there, and lights is a big thing out there, because otherwise it's pitch black. And then we took that to the next level. But, you're on a limited budget, because it's all funded by yourself. And so what can we build here that's like, because, solar's expensive. It's not, the panels are cheap, but, the batteries are expensive, and you need a lot of them if you want to like power lights through the night and stuff. And so we started experimenting with our own designs here, and one thing we realized is like, this whole conversion to AC is very inefficient. If you need more hardware, you lose a lot of power that way. So then what if we do a DC network, and then you as well, the typical 12 volts, a little difficult with the cable distances,
Yeah.
And so then, I looked up what they do on the ISS, for example, and it turns out they use, I think, 120 volts DC.
Oh, interesting.
Which is really cool. But the issue is, there isn't a whole lot of appliances for 120 volt DC. Right. So we ended up settling on 24 volt, because you can find a lot of gear that works on 24 volt. And for like, if you think about the 100 by 100 feet that like a camp roughly there is, you can like, the cables don't get too long, And then another solution we found is like that. We wanted a system that we could keep extending every year. So it needed to be something that's like essentially horizontally scalable. And we came up with this idea of like having just little arcs independent, and that also solved cable length, because we could have them everywhere across the camp, like close to where the power was needed. And that also made it easy to set up, because you didn't have to run cables across the whole place. So anyways, we came up with this like really modular system, and we open sourced the designs. And, I wouldn't say we're the only contributors to like making solar power popular on the playa. But we've certainly like had a fair share of impact there, and inspiring others to build these modular systems, that are very scalable, and very mix and matchable. Yeah.
That it all keeps circling back to Flux, from what I hear. Scalable, modular. Mm-hmm. Yeah.
People often ask me, "Oh, how do you know so and so?" And I'm like, "Oh, I know them for Burning Man." It's like, "Oh, that's interesting. How do you know that other person?" Also Burning Man. And so it turns out that, I always say my hypothesis here is that, since I didn't go to school in the US, I feel like everybody else has a lot of their network from school time, college time here. My network comes from Burning Man.
Is that how you ended up at Facebook?
Yeah, it is. Mm-hmm.
Can you tell me about that transition and what you did there?
Well, the first couple of years here, I was just mostly underway as a contractor. Just, I think I arrived in Silicon Valley a little bit burnt out, and I needed just like some time to explore. And, I loved, my sister went to college here. And that's how I came out the first time here in the late 2000s. And I just loved how open people out to ideas and are supportive. And I felt that was a good place to just overcome my burnout, But so then eventually, right, I wanted to move past that, I'd just gotten married. We were going to have a kid, and I figured, this might be a good time to just have a regular job at healthcare and stuff. And my wife was very supportive of that idea,
I'm sure.
And so then I had a bunch of friends who worked at Facebook over the years. Again, right, because I came here as an immigrant, Facebook had a huge positive impact on my life and just connecting with people here and meeting people and staying in contact. But a lot of the Burning Man maker groups or Facebook groups. And so I was like, this seems like the right place for me.
Yeah.
And so that's how I ended up there. I joined there as a product manager in 2015. And I worked there on what they call the Blue App, the Facebook app. I also worked on the advertising products there on the business side. And then at the end, I worked at Oculus I was involved with the Oculus Quest launch. Yeah.
That's exciting. How was it launching the Quest? I could spend a lot more time than we have time for on that, but what was the Quest like?
Yeah, I agree. We can go deep here. I mean, it was cool, right? The Oculus Go had come out a year or two prior, and that was like a huge success for what the device could do, and it really proved out this idea that there was a huge appetite for like a simplified, untethered device, right? And that if only we could figure out a way to make that more capable, right? With like 6 degrees of freedom, longer battery life, better compute, and we might have something on our hands there. But there was also like, there was two fractions at the company. There was the ones, I think, the hardcore gamers, they didn't care about untethered, right? Or low price point. They just wanted the maximum capable device.
The best possible performance, yeah.
And they wanted that science fiction immersion, and they wanted it now. And that was and then there was the other faction which I say I was probably part of, that we wanted it to be more accessible.
Yeah.
We wanted our mothers to be able to use this. And this was never going to happen with a tethered PC.
The barrier to entry for those devices was so high. So I've definitely seen plug and play being a winning mindset in the long run for things like this.
Yeah, I mean, there was also folks who said, like, look, this is never going to work as an ecosystem if the developers can't make money. And that was really hard with this PC-bound device because the market was so small and there was so many requirements, right? Whereas like with an, more consumer-friendly device, it was easy to use and whatnot. We could address a much broader market, also because the price point would be way lower. And then developers in the ecosystem could actually be profitable. And that the only way to like make VR real was like the developers of these actual applications, of these experiences, were able to have a profitable business, And I would say that's like largely achieved now. There's like 20 million, I think, active devices in the market now. A lot of the developers are profitable. So I think, this ended up going the right direction. Yeah, but it was exciting, to see that actually happening, to see the team pull it off, to get the capabilities into that form factor at the price point. That was really exciting.
My mind is teeming with directions I want to go, but I want to keep it at a manageable arc here.
I'll come again for a pure VR episode.
I'd be even just digging into the Facebook app in 2015 was such a huge part of the culture. Like huge, and it's changed so much in the last 8 years.
Yeah, I left in 2019, so I catched the good times and let's say just like challenging times.
What were your big takeaways from your time at Facebook? What did you learn?
I just had a conversation over the weekend with a friend about that. But I think a big piece for me personally was just getting better calibrated on a lot of things, right? I think on how many brutally, wickedly smart people are in the world and effective, right? Like I had met smart people and successful people before, but not at that scale and so close up that I could observe them operate day to day. And I think that was really helpful for me, The other thing is then, but also to see at the same time that even those people that sometimes just don't know how to solve the problem, and they're also just winging it.
Yeah.
That was helpful too, to be like, look, you have a room with the smartest people I can think of, and nobody has a damn clue why the thing isn't doing what it's supposed to do. And then we'll just shoot from the hip, and then we'll arrive eventually. We iterate towards figuring out why it's broken, I think another one is, maybe like around operating systems at that scale where there's billions of users using it, is that, look, I've done this too before I worked at Facebook, to just from my armchair expert seat here, just be like, well, why aren't you doing it right?
Yeah.
Why you keep doing it wrong? And it turns out there's only bad trade-offs. There's only bad options on the table. And what we were trying to do is pick the least worst one that took into account as many of the parties as we could.
Yeah.
So yeah, and I think that was interesting to see. It was interesting to like again and again have these conflicts and find oftentimes good solutions, but yeah, sometimes bad solutions. And then also like, yeah, sometimes making mistakes and just having to fix them afterwards, right? So I think that was good. The other one I learned is, how the narrative can just get out of control, I think a lot of the negative sentiment we have today was because leadership there let the narrative spin out of control without jumping in with their own version of what happened. And then it's just unstoppable.
Yeah, it's one of the maybe the great mysteries of the tech world is when you get enough smart people and enough, budget into a room, you either walk away with magic or you walk away with everyone going, what were they thinking? And the difference, but the tipping point between the two of those is often not very, very large at all.
Yeah, I read a book as a teenager. I think Jack Welch, the former CEO of GM or so, wrote that. It's called Winning or so. And one thing I remember for the rest of my life was like they did an analysis there what the difference was between successful teams and unsuccessful teams. And there was something about that, an unsuccessful team, they got like 3 out of 10 decisions right. And a successful team got like 4 out of 10 right. Right? So 2 takeaways here was like, A, even the best people get it wrong most of the time, right? And that the difference between success and failure is really slim,
Yeah.
And always keep that in mind, right?
Yeah. Yeah. I feel like that's kind of true with music. It's not so much about getting 10 out of every 10 projects perfect. It's about having 3 or 4 wins really brings the rest of everything up.
Yeah, and this leads to another learning from there. It's like taking a portfolio approach to leadership, right? To say like, look, we're not gonna. But I think in pop culture, there's a lot of lore around focus on one thing, do one thing right, and I think that's just a little bit too extreme for practical purposes. I think for practical purposes, you want to have some sort of a portfolio approach. Yeah, you want to have one big thing you focus on, and maybe that's 70% of your time and resources, and you want 30% maybe spread across some bets. Wherever you land there, right, on your risk versus reward kind of axis, but taking portfolio approach to things. And I think that works well in the work environment, that works well for your personal life too.
So I want to geek out on circuit design and hardware now. How did you... what is Flux and how did you get started in that?
How did we get into this? Like I said, I quit Facebook 2019. I then convinced my wife that I wouldn't just jump into the next job and take like a couple months off. I wanted to take off until after Burning Man and really just go deep on some ideas I had there that that I couldn't execute just from the daily shuttle ride. So she agreed, and so I went in deep, and we got into like, the solar system we talked about earlier. We got to like build a whole system around that, and it was really cool. And like, I wouldn't say mass manufacturing, but manufacturing these, like we call them arcs in a larger quantity than just 2. And that's really how I realized building the 3rd or the 4th one here on the weekends with friends in my backyard. I realized, man, why didn't we make a PCB board for this?
Can you describe what was the arc? I saw a picture of it on GitHub.
Yeah, it's like a decentralized off-grid solar powered system, so you have like these different components. One component can just be a battery, another component is a management system, another component can be a distribution system, or like consumer management system in terms of like what power sources do we turn on off at which times. For example, like simple example, you want lights to run at night, you want some lights to run the whole night, others just part of the night just to conserve energy, right, and stuff like that. And this is like a modular system you can plug and play and extend as you wish, right? And we made this as easy and rugged to use. I think the ruggedness was also another piece here, in that it just had to work in the desert at like 110 degrees. You have this like, it's not actually sand out there, it's dust, and it gets
Yeah.
into everything, and it never comes out again, and it had to survive all these environments. It had to be something also that was like, even when you're exhausted, and maybe under influence, you had to be able to debug and get back to work. There was a bunch of like design requirements there. And, also we wanted to make it easy for others to replicate the design, so they had to be simple enough, for others to do that. So yeah, that was what we were building. And, that iteration was essentially just a bunch of like off-the-shelf components, duct tape and soldered in, I always say in a shoebox as a joke, but really what it was we repurposed toolboxes. Yeah, there's this brand here, Home Depot has them, rigid. We took rigid toolboxes, because they stack nicely, they're pretty rugged, easy to open and close. There's the bottom piece with wheels on, so you can easily, move them around, especially if you have like a lithium ion battery in there, that's nice. And we just coated them white to be more reflective of the sunlight. So we made these and really on plywood boards, as basic as you can imagine, just all these components screwed to plywood boards and then soldered with actual wires together. And so then 3-4 units in, I was like, man, this is like a lot more tedious than I had anticipated. Also to teach people how to build them, to then test them later, right? And I was like, why didn't we use PCB boards here? Weren't PCBs supposed to be the solution for this kind of stuff? And then I remembered it's like, because it sucks to design a PCB. It's absolutely zero fun, right?
It's hard.
Yeah, right? So, and I was like, maybe, but, the last time I had done this myself was like mid-2000s. And so I was like, well, look, it's 2019. I bet you this has like advanced just as everything else. So I started Googling around. I was like, okay, look, let's find here, what is the modern PCB design tool that's collaborative, and all that. Because, a lot of the collaborators weren't necessarily co-located here. They were like on the East Coast and whatnot. And I was shocked that there wasn't anything, that everything I could find looked exactly the way it looked in the 2000s, when it looked exactly the same it looked when I went to school in the 90s, right? And I was like, has there been zero progress here, right? And so then I was like, no, this can't be. I'm probably searching for the wrong stuff. I'm not thinking about this the right way. I'm going to ask some friends. And so I had a friend of a friend who worked at Apple on the iPhone motherboard there. So I was like, hey, what's the story? He's like, oh no, this is the things you found actually way ahead of what we use in here. I was like, what do you mean? Because this is another thing from Facebook, right? At Facebook, they had like incredible internal tooling that was very specialized on the domain of the company, right? Of building social products, which I would say is a huge piece of their competitive advantage that they have. And so I assumed like Apple or Intel must have the same thing. And to learn that it was the opposite, that right? I was pretty shocked, right? And then I told him about like my observation, and he said, yeah, no, you're totally spot on here. And then I started dreaming about what the solution could look like. He's like, yeah, no, this is the solution I would want too. And I was like, weird, right? And so I started talking to more and more people, and then it was always the same kind of outcome, right? Everybody agreed on the problems, agreed on the solution, and yet nobody had come to build it. And I wasn't originally so keen on starting another company, but I came around on that, I guess,
So what does Flux do then? What was that vision that you outlined, and what does that path look like?
I think there was there was something about like just accessibility and collaboration. I wanted this to live in the browser because it's just easier to work with as a user, right? It's easier to share, easier to collaborate. You don't have to install the stuff, don't have to worry about updates, It's like you don't have to worry about files and all that mumbo jumbo. That was a big piece. And then, I think there was a lot of like just in electronics, right? Like in PCB design, especially, everything has to be designed from scratch, right? You want a voltage booster on your board, you're going to design that from scratch, right? You want that ESP32 chip here. Well, you're going to like design the crystal for that now too, It's like this is like as if when I write software, I have to write my own operating system every time, No, I will not build my own operating system to build it to do
absurd.
this. I will not build my own web server, my own browser, my own encryption library. No, I will not do all that, right? I'll take battle-hardened modules here and plug them together. That's what I want to do, right? That's also, if you think about the arcs that we built, that's what made them fun, that we didn't have to build all these individual components. We could just pick one, plug them together, and great. It's just that the plugging together at scale was also tedious. And so, so I think ultimately what the product then became is, I would say, it's on the intersection of GitHub and something like Figma. if for those not familiar, Figma is like a collaborative in the browser, really incredible graphic design tool. And GitHub, probably most people are familiar with. But, I think if you think about GitHub here, the aspect was like an online platform where people in a friendly manner competed to make the best reusable software components, and bring that to hardware and really also enable collaborating with people you don't trust. I think that's really what's at the core of GitHub, that you through a pull request, what they call it, right? You can make a proposal for a change, an improvement to an existing public component. And then the owner doesn't have to trust you at all. They can just read actually for the changes you made and approve them, decline them, ask for changes, and that if you as the person who wanted to help you out don't agree, well, you can just fork the whole thing and make your own variant of it, It's really incredible like that, right? The tools you have there. So anyways, we wanted to bring that to hardware, that piece. And then the other piece from Figma was like that, this like in the browser, real-time collaborative, really slick, fun to enjoyable to use design tool. And so that's what we've built. And so I think, and then we've also tried to just like modern user experience paradigms, like copy paste. You like copy pasting, you can copy paste things in Flux. So a lot of basic stuff, but then also a lot of stuff like baking industry best practices into the tool and abstracting them away from the user. Like what I don't want to use as the user is like draw pictures. I'm not Bob Ross. I want to make a PCB board. That's what I want to do.
I'm so tired of building footprints from scratch.
That too. But it's also like, think about something like shielding, right? Common practice for many shops these days to just flood all the empty space with copper. But that means somebody will sit there and draw polygons all day, and then there you move something. Now they have to redraw these polygons, Right. And so in Flux, by default, we do that for you. And we reflow it automatically, right? You can turn it off if you like to, but by default, you're going to have a ground copper pour, and it's all taken care of for you. You don't have to worry about that anymore, right? And so stuff like that. And that's just the most basic stuff. I think the dream we have here is that if you think about how simple it is today for, say, a 12-year-old to build their own iPhone app and distribute that and monetize that, we want to make that as simple for the 12-year-old to build their own iPhone.
Yeah.
Right? And then think about that the power and leverage you give an individual and what that will do for a team organization then, in terms of like just speed, like, time to deliver a project, quality, because you can iterate more, cost, all that kind of stuff. And then back, right, to what matters to me as an individual, just enjoying building these things and loving going to work every day and get to build another thing or change something or improve something. Yeah, so, that's what we've built. And I think, maybe different than like software development or graphic design is that, hardware wants to be built in the end, right? And you need to source components, and you need to stay within a budget you have, and you need to have the quantities. And so like really building a connected product where like, we have integrations with all the big part distributors in the world. So as you design, you can see what things cost, if they're going to be available in a quantity, if they're going to hit end of life soon, all these, basic things. Another thing we're building towards is just like, right now you can export your Gerbers and you can upload them to, a PCB way or some other manufacturer. But I think we want to really integrate this into the product and say like, look, you want 50, 500, 5,000 units of this. Here are like 3 quotes, one, yes, it's going to take 2 weeks. The other one's going to take 4 weeks. These are the differences in quality. And then you can just, order them straight from there.
Yeah.
And not have to go through all these like hoop jumping of exporting files, converting your BOM file to the right format that this manufacturer will accept and all that stuff.
Yeah. Making sure your stack ups were proper to match the spec. And all. Yeah, so much there.
Exactly that too, right? I mean, like every manufacturer has like slightly different specs for the stack up and stuff, and just having this all built in, like, because that's not the stuff I came to deal with here,
Right.
As somebody who wants to make something.
And you must be thrilled to get out of private beta into actual releases.
Yeah, it went live in February. Yeah. So we've spent like 3 years in private beta. We decided also like to just also build this product in the open, direct feedback from users as we went. So we I think like 3 months after starting, we just started having it available for people and to get feedback and to really like because we wanted to build everybody's favorite tool, our favorite tool and everybody else's favorite tool, right? And that was only going to be possible by getting like feedback quick and directly. And so this, building in public thing has always been big for us. But so yeah, we came out of private beta in February, and it's been really amazing, right? To after working on it for so many years to see it now running wild in the open, and it's been amazing to see what people are building, and it's like such an open-ended tool that it's like great to see people use it in ways that we hadn't anticipated, and so and now as a next step, so that, the company's called Flux, the product is called Flux AI. Flux AI is also the URL, and so we're finally now also launching a community preview of the first real AI feature here, so we've baked an AI assistant, an expert assistant, design assistant into the product, right? And it lives essentially in the chat. So each project has its own little chat thread and comment thread, and you can either project level write messages with teammates or reviewers, or even on the schematic or PCB layout, spatially, right? And be hey, look here, what's this doing? Can we move this closer? But so now you can also interact with this AI assistant here, and it's incredibly open-ended. If you've used ChatGPT or any of those, you get a roughly idea. But here this is focused as to design hardware, and it has this wealth of knowledge of you can just ask things hey, look, did I connect this IC correctly? M2 here, is that, and it'll tell you, what's missing or what you can improve. You can do things hey, look, I'm looking for a cheaper replacement for this component, and it can find you cheaper replacements, or more reliable replacements, or right. You can go also all the way to hey, look, describe what you want to build. We want to build a servo controller based on an ESP32. I need to be able to control 4 different servos with this kind of current or specs, right? And it can create the whole BOM for you, and then you can iterate on it. Be okay, that's great. Can we add this? Can we add USB? I don't need Wi-Fi. All these kind of things.
And it's pretty early days for this AI Copilot. It won't even have been out for a week yet when this podcast comes out.
And this is very early here, but it's incredibly exciting, open-ended. So we're really excited also to see how users are going to use it and what the use cases are. And we're adding capabilities. Right now, it can only read your project's information as you interact with it. But I think, there's huge use cases also in allowing you to actually make these edits it proposes. Right? You forgot to connect a pin or something, well, why doesn't it just connect it for you? We've talked to engineers in the past where they need to move 100 traces. They actually outsource that, and
sure.
we want to have the AI do that, and make it more a conversation with your design. Be hey, look, let's make this tighter. Can we move this? Can we whatever you want to do here, or get suggestions. How to make design this board more reliable.
Yeah,
like a flex board, for example. A lot of people are afraid of designing a flex board because they don't consider themselves an expert, and there is a bunch of call it forbidden knowledge around flex boards, for example, or antennas, and making that more accessible that way and less scary.
You mentioned you saw some use cases that surprised you. Where did you expect people to go with it, and what were they doing? And then what were some of the surprising uses?
Yeah, a fun one I've seen, when you create a new project in Flux, we give it a random name. And this project was something with gold was the name. I forgot what it was. And then so the user here asked just the AI system for an idea what to build today. And so the AI system picked up on the title having gold. It's well, you want a gold shredding or digging machine or something. Let's build that. And then proposed a whole BOM to do that, right? And then he was okay, for motors here, what motor would be used for such an application? And then it actually came out, hey, look, for this kind of application, this is the kind of characteristics of motors you're looking for. Here are the manufacturers that make such motors. Here's the motor we could use. And it's going to cost this, and I'm that's, how much time that would have taken to do yourself?
Yeah.
Because I've done this. You can speak weeks, researching components, and here within seconds, you had it all. It was all there for you. So that was a cool one. And I think it's cool because it is you can tell that the thing is creative. It can come up ideas for you. If that's your problem. And maybe that's not so useful for a whole project, but for solution finding it is, right? Yeah. And another thing I personally found is just, especially when I come to other people's design, it's why is it this way? This component, what's it here for in the circuit, And that it just can explain that to you.
Ooh, that'd be nice.
I love learning. I love learning new things. And it's just learning on steroids now, because I can very contextually, spatially in the project, ask questions like that.
Yeah, it helps you where you need help and lets you do your thing where you want to do your thing, which is really interesting.
Yeah, exactly, right? People always ask me, is it going to cost me my job and stuff like that? And I think the way I think about it is this, right? Just because a car can outrun a human, we're not going to consider a car a runner. It's just like it can do that one thing really, really well, and it does it in a really different way, and that has advantages, right? But it doesn't make the car a human. And so I think it's the same here, right? I think this augments the human. This is the bicycle. This is the e-bicycle for the mind.
Yeah.
To build on that analogy of the bicycle of the mind that Steve Jobs likes. So yeah, I think we're building something really exciting here, and we want everybody's feedback and to be part of that. I think we're incredibly early in our journey, and I just invite here the listeners, if this today intrigued you, come join us and help us. If it isn't already the tool of your dreams, to make it the tool of your dreams. Because that's what we want to do here.
Yeah, I had ChatGPT write me some Arduino code, and except for the fact that it made up a library that didn't exist, everything else worked great once I fixed that.
Yeah. I've had that happen too. It's like, nice. There's a library that does that? I didn't know that. It turns out it doesn't exist, but it should exist. Yeah, I had that too. But this is another thing it can do, right? You have a schematic here and be like, hey, look, can you write me some firmware here for the microcontroller to do this in the circuit? And it does that, right? And it's like
wonderful. Yeah.
It's incredible. And we're working on reducing the hallucinations for sure. That is definitely a challenge.
Yeah, I'm very excited about the future of PCB design and where this is going and how accessible it's becoming, because it has been much like music. We're in an era where it's traditionally required big enterprise grade tools, and now it doesn't. Yeah,
and not just tool to create music, but also to distribute it, to market it. But it's been fully democratized. You can market your music on social media, you can distribute it on Spotify or any other platform. And you can make it on your laptop or on your phone even these days, right? So, I think, we want to do the same for hardware.
Well, as we wrap up in time, we like to do a lightning round, ask our guests some quick questions, quick responses. As I'm sitting here listening to you talk, in my head, I'm like, I don't have to mess with your EQ at all. What is your audio toolchain that you're using right now?
It's an SM47, like the standard broadcast. Sure, whatever the model is, and then I have a Scarlett audio interface, and then just via USB in my computer, nothing more.
Okay, well, it sounds good.
Thinking about though getting some analog compression, some tube compression for the microphone.
Yeah, I'm running a DBX 286S.
There you go,
and that's really nice. A little bit of compression, a little. Yeah, it's fun. I could continue to geek out on audio, but I'll spare you. I was not underselling your music prowess. Can you flex a little bit for me? What sort of success have you seen on music tracks you helped work on, maybe in dollars or tracks?
So in dollars made, it's close to $1 billion.
Wow.
It's like $700 million or so. And this is like 10 years ago. So it's hard to count the stuff, but that's what it was about 10 years ago. And then in copies sold, it's hard to say, especially with streaming now, is that a copy or not? Who knows? But probably in the billions, yeah.
Do you have a favorite track that you've produced that people could go check out?
Favorite. It's not the simple answer is
showcase.
Most popular, maybe. Not my favorite necessarily, but most popular. Yeah, I made. If you ever heard of the Crazy Frog,
Yeah.
There was a song called XLF. It was a cover of the Beverly Hills Cop movie. I made the music on that. I didn't make the animation or any of that, but I made the actual music on that. And that's one of the most popular videos on YouTube. So just look up Crazy Frog. You'll find that.
Okay, this is Daniel from the Editing Bay. I was familiar with this song, kind of nostalgically, and I imagine a lot of you are also, but I looked it up. This video is the 14th most viewed video ever on YouTube with 3.87 billion views. Following this, with less views than this video, are Sugar by Maroon 5, Roar by Katy Perry, Counting Stars by OneRepublic, and Sorry by Justin Bieber. He's beat out all of these with 3.87 billion views. This is an iconic piece of music. I'll try and play a clip for you. Anyway, peak 2009, back to the interview.
That came originally out as a ringtone in like 2004, 2005. And yeah, it like in the UK, it knocked Coldplay off the charts, off the number one spot, which is like, especially on Christmas time in the UK, it's like a very like big thing. Who has the number one spot on Christmas week, Yeah.
Well, that is an unbelievably fun thing and really takes me back. Next question. What is your favorite shareable memory from Burning Man?
Ooh. Shareable. It's just many of these things that just don't make much sense, if you weren't there.
That's fair.
I mean, the story I shared earlier, I believe it is like walking down that road there my first night with that predator on the surfboard. It just blew my mind because this is like there was much more to the scene, and there was just anywhere else you go. Let's say you go to Disneyland, right? It's all very like organized and thematic, right? You're now in Mickey Mouse land, or you are in the Star Wars land, and they don't mix these things, right? And at Burning Man, there is no such curation happening, so it's everything all the time, everywhere at once, and it can be very overwhelming, but it's also just very great to see, that humans can create a space like that and coexist, on all these different levels of creation and participation. Because it isn't just about the costume you wear, even. That's also just like reducing it to something it isn't, to me at least, right? It is like, for some people it's a costume. For other people, it's music they make. For other people, it's drugs they take, right? For the next person, it's like they serve tea for others. I mean, it happens on so many levels, and that's also cool to I guess there is a creative competition there into finding new ways to cause delight or to trigger you, I guess you could say, something I did last year. I brought a leaf blower, and a lot of people out there surprisingly hate the dust. And then you coming in with a leaf blower, you will be able to quickly tell who loves the dust and who hates it, because the dust is like very light, and the leaf blower there, you can create like massive clouds in no time of dust that just roam through the city.
A little bit of chaotic behavior there.
There is an element of snark in the culture there, and of being instigators of positive and triggering things. And so, and it's fun to come up with new ideas how to trigger people in different ways, through large things you do and small things you can do.
What advice do you have for future engineers or people who are trying to carve out their path in tech?
Give yourself permission to dream big dreams. You wouldn't believe the people I met on just doing Flux who tried to tell me that it was going to be too hard, too much work, and it's too complicated, and just this one thing is going to be an incredible amount of work. And look, and if you listen to these naysayers, you're never going to do anything worthwhile, I think. You just need to be like ignorant to some degree, and also be willing to fail, and sometimes the other people are right. Yeah. And dream big, I think like one thing when I did, the original research here, I realized a lot of people had tried to solve some subset of these problems through a plugin into existing tools, or through, people that tried to build the GitHub of hardware, but these were all too small of dreams to make any meaningful change, and that's why there's such a graveyard of these attempts. This problem here was so big in this industry, and the industry so far is decades behind, probably 30, 40 years to something like software engineering, right? That you just need to like start from scratch here and build everything from scratch.
Yeah.
And that's scary, and it's a lot of work. Don't get me wrong. It's very hard. But then, what else were you going to do with your time that was worthwhile?
Yeah, one of my coworkers says if it was easy, we'd all be out of a job. So, well, thank you so much. This has been a blast.
Yeah, likewise, Daniel. It's been a great pleasure to be here. And the next time I come on, we can geek out more in VR.
I would love that. To the folks listening, if you want that episode, let us know on the Moore's Lobby social pages. And while you're there, tag someone who you think will like this podcast. Telling friends about Moore's Lobby is the highest compliment you can give us. And also, we're giving away swag. That's it for today. That was Matthias Wagner, CEO of Flux. Please make sure you are subscribed to this podcast in your favorite podcast delivery mechanism, including YouTube. And thank you for joining me today in the lobby. I am Ghost of Electronics past Daniel Bogdanoff. And was that a Christmas Carol reference in May? Yes. Yes, it was. See you next time.